All right, so you're a master of SQL, right? It's how you talk to your data. But what happens when your data gets so big, it's not just talking, it's shouting. So loud that your database just can't handle it anymore. Well, today we are talking all about Spark SQL. It's the tool that lets you use the language you already know and love to work with the wild world of big data. Let's get into it.
So let's talk about a situation that probably sounds familiar to a lot of you. You've spent years getting really good at SQL, but your data sets have just exploded in size. They're way too big for a traditional database now. So what does that mean? Is all that hard-earned SQL knowledge suddenly useless?
No way! And that's exactly the problem Spark SQL was built to solve. It's the bridge that connects your powerful SQL skills to these massive distributed datasets. It basically lets you speak the familiar language of databases to the new, much bigger world of big data. Okay, so at its core, Spark SQL is a Spark module made specifically for structured data. You can think of it like a universal translator. It lets you write queries using the standard SQL you already know, or if you prefer, you can use something called the dataframe API to work with the data programmatically. It's super powerful. But hang on, how does Spark even think about a table when the data isn't on one server, but scattered across a whole cluster of machines, right? A regular table sits in one place. To make this work, Spark needed a whole new way of thinking about structured data. And that new way of thinking is the data frame. Now, it was originally called a schemardd, and that name actually tells you everything you need to know. It's just like a standard Spark RDD, this unchangeable distributed collection of stuff, but with one absolutely critical addition, a schema. It knows the column names, it knows the data types, it actually understands the structure of your data. And that one difference changes everything. A regular RDD is flexible, sure, but to Spark, it's basically a black box. It has no idea what's inside. A data frame, on the other hand, is like giving Spark the blueprint to your data. And because it has that blueprint, it can perform these incredible optimizations under the hood, making your queries run, dramatically faster. Okay, so now we have our distributed table with a schema. We've got the what figured out. So the next big question is, how do we actually run a query on it? How does this work in practice? Well, it's actually surprisingly easy. It's pretty much a simple 4-step recipe. First, you create your entry point, which is called the Hive context. Second, you load your data. Third, you register that data as a temporary table and give it a name, like, say, users or sales. And what's the last step? You just write SQL. That's it. And when I say SQL, I really mean standard SQL. The syntax is going to look almost exactly like what you're used to. Now, technically, it's a variant called hiveql, but here's the key takeaway. You do not need to learn a whole new query language just to unlock the power of Spark. You can use what you already know. And you're not stuck with just one kind of data format either. Spark SQL is incredibly flexible. It can read semi-structured JSON files and figure out the schema on its own. It can work with these super efficient columnar formats like Parquet for amazing performance, or it can even query tables directly from an existing Apache Hive data warehouse you might already have. Now, this next part is where Spark SQL goes from being just a really powerful query engine to an absolute game changer for development. It doesn't just let you run SQL, it lets you weave SQL directly into your application code. Just stop and think about what this means for a second. You can use SQL for what it's amazing at, quickly selecting, filtering, and aggregating data. Then you can take those results and right there in the same program, feed them into a machine learning model with Python or apply some really complex business logic using Scala. It all just flows together in one application. The magic is really in this workflow. You run a SQL query, and what Spark gives you back isn't just a static result set, it's another data frame. And because it's a data frame, you can then apply all your programmatic RDD transformations like .map or .filter, and then guess what? You can run SQL on those results. You get this amazing, powerful cycle of SQL and code working hand in hand. So of course, this is all great for developers. But not everyone who needs this data is writing code, right? What about all the analysts and business users who live inside their business intelligence tools all day? Well, Spark has an answer for that too. It provides a standard jdbc/odbc server. The best way to think about this is like a universal adapter. It just acts as a gateway, allowing any standard BI tool, like Tableau for instance, to connect directly to your Spark cluster and run queries just like it was talking to any normal old database. And you really can't overstate how huge this is.
It means your entire team can tap into the unbelievable scale and power of a Spark cluster, but they can do it from the comfort of the BI tools and dashboards they already know and use every single day. You don't have to retrain your team. You just get to supercharge their engine.
So this brings it all back to you. We've seen how Spark SQL lets you take the skills you already have and apply them to basically limitless amounts of data. So the real question to think about is, what kind of amazing new insights are just waiting for you to find now that scale isn't a problem anymore?
And that's our look at Spark SQL. Hey, if this helped you connect some dots, do us a favor and like, share, and subscribe for more explainers just like this one. Thanks for watching.